If you've ever tried to make an AI model talk to your tools or your data, you've probably realized something. It's messy. Every API behaves differently. Every integration needs custom code, and every time the model changes, your connection breaks. The Model Context Protocol, or MCP, was created to fix exactly that. By the end of this video, you'll understand what the Model Context Protocol actually is, why it exists, and how it's changing the way models interact with the world. We'll walk through the core ideas step by step, see how it compares to traditional APIs, and talk about what this means for developers building agents or AI-powered applications. So, what is the Model Context Protocol? At its core, MCP is an open standard for connecting models to tools, data, and context in a really consistent and structured way. You can think of it as a shared language between models and the systems around them. It defines how a model can discover available tools, ask for information, and perform actions without having to know the specific implementation details behind each one. This protocol was introduced by Anthropic and is now being adopted across the industry because it solves one of the biggest pain points in AI development today: how to make models use external resources safely and reliably. So here's why that matters. APIs were never designed for AI models. They were designed for programs that already know exactly what they want, programs that can form precise, deterministic requests. A language model doesn't work that way. It generates text probabilistically. It reasons about uncertain inputs and often needs to ask questions, clarify, or explore before it knows what to do. MCP bridges that gap. It gives models a structured way to discover and describe the resources they can use. So things like functions, datasets, documents, or prompts are all available through a consistent interface. Instead of hard coding every integration, the model can now dynamically query what's available, use it, and even chain multiple tools together. So all while staying within a safe, standardized framework. To understand how MCP actually works, let's unpack the main idea. The protocol defines two sides: clients and servers. The client is usually the language model or the agent system that wants to perform a task. Something like Claude, Gemini, or an agent built on top of OpenAI or Google's frameworks. The server is the environment that exposes resources that the model can use, like a database, a file system, a company's internal tools, or even a document search engine. When the client connects to the server doesn't just respond with data. Instead, it advertises what capabilities it supports, what resources exist, what actions can be taken, and what inputs are required. This means the model doesn't need to be pre-programmed with every API or every endpoint. It can dynamically discover them. The communication between these two sides happens through a really simple and well-defined schema. The client sends requests like list available resources, call this action, or retrieve this data. The server then responds with a structured JSON describing what's possible and what happened. That's the essence of MCP, a standardized way for models to talk to their environment. Now, let's go a bit deeper technically. The MCP protocol defines a few main resource types: tools, prompts, resources, and context, that together form what the model can see and use. Tools are actions that the model can invoke. For example, a tool could be a search database, send email, or even analyze a file. Resources are pieces of data and state, like a text document or database row or even an image. Prompts are reusable templates that describe how the model should behave for specific tasks. And context represents external information that the model can pull into its reasoning process, things like recent chat history, company data, or user preferences. When an MCP client connects, it can request a list of all of these things from the server. Each tool or resource comes with metadata that describes what it does, what input it expects, and what output it returns. This allows models to interact intelligently. The protocol enforces a consistent schema across all tools, so whether the model is using a GitHub server, a CRM server, or a calendar server, it speaks the same language. Now, let's address the big question. If we already have APIs, why do we need MCP at all? The answer comes down to who the consumer is. APIs were designed for programs written by humans. MCP is designed for models that reason like humans. You can think of MCP as an abstraction above APIs. APIs still exist. MCP just makes them model-friendly. Under the hood, your MCP server might still call your existing REST or GraphQL APIs. But the model never sees that. It only interacts through the structured MCP schema, which handles discovery, validation, and execution in a uniform way. That's what makes MCP powerful. It lets you expose your system to any compliant model without custom integrations each time. Let's take a practical example. Say you're building a personal assistant agent that can check your calendar, pull meeting notes, and draft follow-up emails. In the old world, you'd integrate with Google Calendar, Notion, and Gmail APIs. You'd write code for each service, handle authentication, rate limits, and all of the weird edge cases. Then you'd teach the model how to use those endpoints through really long, fragile system prompts. With MCP, you build or install servers for each of those systems, a calendar server, a note server, an email server. Each one advertises what it can do. The model automatically sees the available tools, like list events, get meeting summary, or send email. It can reason about what to use, in what order, and what data to pass between them. The key difference is that the developer doesn't have to write glue code for each new tool. The model knows how to interact because the protocol is consistent. That's the kind of simplicity that MCP brings to AI development. So this shift is already underway. The same way that HTTP unified the web, MCP is already beginning to unify how models talk to tools. And that's why learning it now matters, because soon every serious AI developer will need to know how to make their systems MCP aware. For a full list of Google Cloud-related MCP servers, check out the description box below, as well as a blog post regarding how MCP servers work. I hope this video was helpful. If you want to continue watching and learning about MCP and APIs, check out the next video called MCP versus API.